Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to learn about where acute triangle trigonometry can actually be applied in real life. As part of this, we're going to choose the best strategy to actually solve a triangle. We're going to learn how to use that trigonometry to actually solve problems in our life. And you're good at this when you can determine any side length or any angle in an acute triangle using the sine law or the cosine law. Also, you're going to be able to solve problems that involve the sides and angles of acute triangles. To get started, let's create a flowchart that we can use to help us solve any acute triangle, so to find any side lengths or angles. Now, we've learned a lot of different strategies by now. Hopefully, you know some like the primary trig ratios or the Pythagorean theorem or even the sine law or cosine law. But which one should you use if you see a triangle that you need to solve for? Pause the video here and see if you can do this. Create a flowchart that will help you choose the best strategy to use in any situation. Hopefully, you recognize that the first question, well, I don't know, hopefully if this is the flowchart that you came up with, but certainly the way I came up with it was I tackled it by asking myself, okay, well, the sine law and cosine law don't really apply to right angle triangles. Those are the hard ones. So the first question I'm going to ask myself is this a right triangle? Because if my answer is yes, then I definitely don't need the sine or cosine laws. If it is a right triangle, then I'll probably need either the trig ratios or Pythagorean theorem. Which one? Well, it depends. Am I trying to find a side length? If I'm not trying to find a side length, then SOHCAHTOA is the only way to do that. This is the only way to actually find an angle, right? Because you need the ratios, the trig ratios, to solve for that. But if I am trying to find a side length, then there's one more question I do have to ask. Do I have an angle? If I have an angle, then the ratios would be really useful because it is a right triangle, so that's a 90-degree angle. If I have one other angle, and of course, hopefully I have a side length by now because it's not possible to solve a triangle if you don't have three pieces of information. So if it's a right triangle and I'm trying to find a side length and I have an angle, the trig ratios can help me out there too. But what if I don't have an angle? Well, that would mean I know it's a 90-degree triangle and I should have two sides. And if that's the case, then the best strategy to use would be the Pythagorean theorem, or Booleanus theorem as I call it. And those are our strategies for solving a right triangle. Really, these are the only two. The problems really become a lot harder when we get into answering that question with a no. If it's not a right triangle, then we need to look at the sine or cosine law. And the way to distinguish which one we can use is just by asking the question, do we have a pair? Do we have an angle and the opposite side length? If the answer is yes, then, okay, well, do we have another angle? If that answer is yes, then we're going to use the version of the sine law where the side lengths are in the numerator, right? Because we have a pair and we have another angle, which means the side length is the only unknown that we can solve for. But if we don't have another angle, that would mean that we must have another side. And that would mean we need to use the version of the sine law that has the angle in the numerator. So we have a pair, we have one more side, and that would mean we're solving for this unknown angle. If we don't have a pair, though, so if the answer to this question is no, well, then we can't use the sine law. We must use the cosine law. But there's, of course, two different ways we can do that. We can either solve for a side or an angle. If we do have three sides, then we're definitely going to be solving for the angles, and we would use the version of the cosine law that has the angle isolated. But if we don't have three sides, which means we have two sides and we have the angle in between, right? So it's not a right triangle, it's an acute triangle. We don't have a pair, so we can't have any angle that is opposite a side. But we don't even have three sides. We have two sides. So if we have either of those opposite angles, then we would have a pair, but that's not true. So that means we must have two sides and the angle in between, and that means we need to use the cosine law version that has a side length isolated. So here we go. This is your entire flowchart on which is the best formula to use in which situation. We have 1, 2, 3, 4, 5, and 6 total situations. So start thinking about this in the right way. My friend Annie wants to measure the width of a river, but a river is very hard to measure, especially when you cannot get to the other side to stand on it because there's a giant cliff in your way. How could she still measure the width of this river? Pause the video here and think about that for a minute. Well, in this case, because she has a protractor, one of the things she can actually do, and this is a neat trick, you can find a landmark. So in this case, she's found this little crack right here in the cliff, and she's gonna stand across the cliff face, across the river from that crack, and she's gonna put a protractor right there. And if you look straight down the protractor over here and make sure that it's 90 degrees, you can see that you are exactly across from it. Then, if she can stand over here and do the same thing, put the protractor in a way that the 0 degrees is pointing along the length of the river, so it's flush with the river, and then look down at that same feature, in this case, the crack, she might see that, hey, that is about a 40-degree angle. And she might say to herself, I went from here to here, and that was 50 feet. So by doing this, she's created a right angle triangle. And because she knows this length and she knows one angle, well, plus the right angle itself, she knows that, well, this is the adjacent side, this is the opposite side, and this is the hypotenuse when we're talking about this 40-degree angle here. And so if I'm trying to find out the width of the river, that's the opposite. I know that the adjacent side is 50 feet. So opposite and over adjacent involves the ratio tan, especially because this is the angle that we know. So tan of angle 40 is equal to the width of the river divided by the adjacent side, which is 50 feet. And if I want to isolate W, I just multiply both sides by 50. And that tells me that the width of the river, or that the river is about 42.5 feet wide. So, in a nutshell, trigonometry can be used to measure the 3D world around us. We can use it to even measure distances that we can't actually reach just by recognizing that some line segments that we might be able to create do form angles in between them, and we can make triangles out of that. If you work as a surveyor or a cartographer, you might use trigonometry to find the width of something that you can't cross or the width of something that you can't reach, like a river or a road or even a canyon. If you're a carpenter, you might use trigonometry to measure distances for furniture or for a building that you are actually building, I guess. And the way to use trigonometry in these ways is always to first draw a diagram of your situation and then choose the best strategy. And the flowchart for a strategy is more or less, is it a right triangle? If the answer is yes, do you know any angles besides the 90? If your answer is yes, then definitely use the trig ratios. But if you don't know another angle besides the 90-degree angle, but it is a right triangle, then you should use Pythagorean theorem. If it's not a right triangle, though, then you're in a little bit of hot water, but we still have strategies to deal with that. If we have an angle side pair, we use the sine law, and if we don't, then we use the cosine law. In this example, a DJ is playing in between two spotlights that are mounted 5 meters apart on a track on the ceiling. He estimates that, okay, if this is 5 meters apart, then the red one is at an angle of 50 degrees, and the blue spotlight is at an angle of elevation of 60 degrees. And of course, just like I did over here, because the ceiling is parallel to the floor, that means that this is 50 as well. And that means that this is 60 as well. Using this information, I can see that there is a triangle happening here. And if I want to find how high the lights are, here's how I might do something like that. And you can pause the video and try and figure it out yourself if you'd like. Remember, we're trying to measure this distance. How high are the lights above the floor? So hopefully you recognize that, okay, well, if these three need to add up to 180, then if I subtract 60 from both sides, I'll see that this angle over here is about 70 degrees. And now, why are we measuring that when we're actually looking for the height? Well, I'll tell you. In order to find the height, we need to create some sort of a triangle. And I can see a triangle happening here, but to do that, I need to know the length of this side to use it to find the height. Because right now in this triangle, the only thing I know is that this angle is 60 degrees. I know that this side is less than 5 meters, but is it 3.1? Is it 2.95? Is it 2.12? Who knows? The DJ is not exactly in the middle, otherwise both of these angles would be the same. So one way to solve this is to find out what x is first. And we can do that using sine law because we actually know that the track is 55 meters wide and this angle here is 70 degrees. So that's the reason I'm using sine law, because I have a pair. 5 over sine 70 should equal x over sine 50. And if I multiply both sides by 50, I'll see that the track is 4.07, or sorry, that this distance is 4.07 meters. Now it's time to find the actual height. Well, if that's 4.07 meters, and I can make a right triangle kind of just like this, I'm going to move that back. Well, then this is the angle, this is the hypotenuse, this is the adjacent. And so the sine theta, or is going to equals opposite of hypotenuse, is going to end up turning into sine 60 equals h over 4.07 with repeating decimal places. Now I want to get h all by itself, so I'll multiply both sides by 4.07, or I'll take my answer and multiply it by sine 60, and I end up getting about 3.52 for my height. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.